Hey everyone, Brandon with FastDataScience.ai here. And in this video, I want to tackle a question that I often get from young, aspiring data scientists. And that is essentially, what environment should I choose to learn data science with? And invariably, we end up getting in conversations around the distinction between a data science platform versus an IDE. So spoiler alert, the distinction is actually pretty straightforward, but it's an important one. So let's go ahead and tackle what each of these mean in the data science context. So an IDE is just an integrated development environment. All that really comes down to is that IDEs are single software applications that allow developers to enter code, test their code by running it through the interpreter, and debugging to develop and do research with data. One of my favorite applications that helps to enable this is Spider. We'll take a look at Spider in a few different examples. Probably the most popular IDE is Jupyter Notebooks, which is a browser-based IDE. And then finally, you also have a lot of other IDEs that other developers have learned and chosen to enjoy for whatever reason. Things like PyCharm, VS Code, all represent different IDEs or integrated or interactive development environments. For example, here's a picture of a screenshot of Spider. So you'll see in Spider, you have three panes. On the left-hand side, you have a way of entering code and creating and saving that code as files. On the right-hand side, on the bottom, you have a way of submitting that code to the interpreter to test it, or for research purposes in processing and evaluating data. On the top, you also have the ability to examine variables that are created in the process of testing your code. It's one of the reasons why Spider is a really good tool for research purposes, because you can see what's being created in real time and interact with data that way. Okay, so what's a platform? A platform, in the data science context, is integrated with multiple services, including IDEs. So platforms really just allow us the opportunity to access multiple services, multiple tools, and multiple technologies that allow us to do even more with our data science development. In a lot of cases, or in most cases, these data science platforms enable managed compute resources along with the instantiation of those IDEs, so that you, the developer, don't necessarily have to figure out how to configure any compute environment to be able to launch that particular IDE of choice. You can see this comes with a lot of benefits in terms of being able to scale compute very easily in a way that abstracts the compute environment away from the developer, reducing the skill set required to access some of those more robust compute environments. Data science platforms also come baked with lots of other services, not just compute resources, that help to manage those IDEs that are delivered back to you in a development context. Some really popular platforms include things like Databricks, SageMaker on Amazon, Dataiku, also IBM Watson Studio, and Domino Labs. All of these represent various data science platforms that integrate multiple services, one of which being an IDE for you as a data science developer to go about doing your development work. So here's just one example of what I mean by bringing multiple services together to enable more than just data science development that the IDEs enable. So in this case, we're looking at Databricks, which is comprised of workspaces that are Jupyter Notebook-driven IDEs, and then those come attached to other services, other technologies that help to enable more capability on the platform, particularly around the use of scalable compute, the use of and configuration of Spark across that scalable compute, and other services that allow us to deploy models or track experimentation, things that aren't necessarily available in a single IDE application. Okay, so now if you're wondering, so where should I start? What exactly should I learn? Let me go ahead and answer that question for you. If you're a data scientist learning and getting started with the field, I highly recommend Anaconda. Anaconda is sort of like a platform light. It's a platform you can download directly on your own personal home laptop, and you can do it for free. Anaconda comes with multiple IDEs, particularly the two most popular IDEs, Jupyter Notebooks and Spider. So you get the opportunity to be able to develop and become comfortable with development using IDEs that are commonly used in the larger data science platforms. So if you're really wondering whether or not a platform makes sense for you to begin learning, my advice to you would be hold off. Platforms are really meant for larger enterprises and are also going to come often with more expenses. You can learn all the tools and tricks of data science leveraging Anaconda and learning the IDE environment. And then once you've developed those skill sets, as you start to scale your data science into other areas and for other purposes with larger data sets that have a bigger business impact, then you can start to look at how you leverage those platforms to be able to make those deployments easier to you as a developer. All right, so let's talk really briefly about what Anaconda is and how to access it. So Anaconda, I'm going to slide over here to my browser, as I mentioned, is simply a tool that is sort of acting like a platform in that it provides us with multiple applications all in one download. In addition, those multiple applications, Anaconda helps us to manage the typical Python environment that's required to be able to use those applications to do our development work. So, for example, Anaconda comes with other tools like virtual environments and also allows us to keep track of some of the different system environment variables and functions that we may require to be able to perform more work within the context of multiple virtual environments. Anaconda comes on all of the different platforms or the major platforms for compute, including Windows, which is the machine I'm on, Linux, as well as Apple. Once you've downloaded Anaconda, the best way to access it is through the Anaconda prompt. So whenever you access the Anaconda prompt in Windows, I simply click the Start button. And when I start typing Anaconda, what comes up is an icon that looks like this that says Anaconda prompt. In this case, I'm using Python 3, so it's Anaconda 3. And if I click on it, my Anaconda environment is launched from the command line. And so here I can actually ask Anaconda to launch other applications like IDEs to do my development work. For example, if I want to launch a Jupyter Notebook environment, I type in Jupyter Notebook, hit enter, and in just a second, you'll see that under the covers, Anaconda is launching a server that allows you to use your browser to connect to a Python interpreter and do your development work in a browser-based IDE. Again, also known as Jupyter. So Jupyter is loading. Here's an example of what Jupyter Notebooks looks like upon load. And so in this context, you have a file system available. You can launch a new notebook using our Python 3 interpreter. Again, Anaconda is helping to manage all of this under the covers for you, so you don't have to tell Jupyter where to find all of these things. That's why I sort of refer to Anaconda as a platform light. Once the notebook is launched, we'll then be able to start actually entering code and running different cells of the notebook to be able to experiment with. In addition, we can also launch Spider in the same way, directly from the Anaconda prompt, by canceling out of our notebook. Escaping the kernel and typing Spider and hitting enter, our Spider environment will get launched and it'll look something like you saw in the screenshot, like this, where we can enter code, we can run that code in this interactive interpretive plane, and we can also see the variables and other things that we've created. So in that context, I hope you've learned a little bit about the difference between platforms and IDEs. And I hope that I've convinced you that Anaconda is a really good solution because it gives you access to different IDEs, particularly two very popular IDEs that are commonly used in the more complex data science platforms that allow you to go beyond just development and into deployments and monitoring and all the other tools and functionality that those platforms enable. Thanks for watching. I look forward to doing more of these with you. I hope you have a great day. Bye.